Okay, this is day 12 of the second distance learning packet for 8th grade. And the first part is a task. And this is something that you are going to need a piece of paper for. So you're going to fold it. And you're going to write down the number of layers of paper after each fold. So imagine we have a piece of paper. We fold it in half. Okay, so there's 2 layers of paper. And that's shown here. And we fold it again in half. And then that's going to give us 4 layers of paper. And then we fold it again in half. And then how many is that? It's just going to double each time, right? So it's going to be 8. We fold it again, it's going to be 16. Fold it again, it's going to be 32. And then if we write that as an exponent, and we give the first 2 for it, they do the first 2 for us. So it's 2 to the first power. So 2 to the first power is 2. 2 to the second power, 2 times 2 is 4. So this would be 2 to the third power. 2 to the fourth power, 2 to the fifth power. All right, so then it goes on and on. Now, in real life, we can't keep folding. There's a certain number of times we can fold a piece of paper, and then we can't fold it anymore. So this is going to move into the theoretical, just mathematical model of this situation. So if we could fold it 10 times, how many thicknesses or how many layers of paper would there be? So if we keep following the same pattern on the bottom, so how do we get that exponent? So if we look at this exponent, say we have the 5 here, okay, that's the same number as here. The 4 and the 4, so it's the number of folds that becomes our exponent. Okay, so let's use that same pattern and write in here 2 to the 10th power. So then how many layers of paper would that be? What is 2 to the 10th power? So I'm going to use a calculator. So 2 to the 10th is 1,024. 1,024. And then we keep going 2 to the 100th power. So we can't obviously keep folding a piece of paper this much, but let's see what it would be if we could. Okay, so we get this number. All right, so this is scientific notation, which is one of the last things that we studied, and this is a way that we can write really large numbers and really small numbers. So it just means there's a lot of zeros on this number. It's a really big number. So I'm going to write 1.27 times 10 to the 30th. 1.27 times 10 to the 30th. So that is a very large number. And again, we could not actually fold a piece of paper that many times. But that's what it would be. That's how many layers of paper there would be if we could. Okay, the nth term. So that just means for any number of folds, how many layers of paper would we have? And this is where we get our equation, like with the variables, the x's and the y's. So this would be 2 to the nth, and then we don't really put anything here, but we could give it a variable, maybe P for paper or F for folds. Oh no, layer. This would be layers. So I'm going to do L. Lowercase l. So my equation, if I wanted to know how many layers of paper there would be for any number of folds, I would write it like this. Or where these two are the numbers of folds, number of folds, okay, and then this would be the layers. So we can actually graph this. We can get any number of layers of paper after any number of folds. All right, so let's continue. So here's a maze and a puzzle. So I'm not going to do this for you, but let's just make sure we understand what's going on here. So it says we need to find the correct path through these boxes, and the solution is a famous quote from the U.S. history, which is going to be in the bottom there after we find our numbers. Okay, so it says start with box 1. Draw an arrow to the box next to or diagonal to box 1 with the expression of the least value. The arrow cannot go to a box that has already been used. The first arrow has been drawn to get you started. So what do we have to do first? So it says the least value. So what are the values of these numbers? Right? So I would go through first and evaluate these exponents. So the first one, we've already done this. 5 times 5 times 5, 125, that's the previous day activity. And then 2 to the 7th, okay? So 2 to the 7th power. And again, if your calculator doesn't have that exponent button, you could do 2 times 2 times 2. So do that 7 times, and we would get 128. So it says the least value, okay? But 128 is not smaller than 125. So it's not talking about the least, less than, it's the least of the choices we have around it. So 13 squared is 169. So 128 is smaller than 169. 6 to the third power, 6 to the third power is 216. So out of the boxes that are adjacent or next to box 1, we want to go to the box that has the least value out of those. So out of those 3, 128 is the smallest number. So that's where we head to next. Okay, so box 1, and it corresponds with the letter G. So that's just looking at our decoder over here. Okay, so then box 7 is I. All right, so then we just keep going. So now from box 7, we want to look at next to or diagonal. So we could go here, we could go here, we could go here, we could go here, we could go here. And as long as it hasn't been used yet, actually we can go here or here because those have not been used, right? So what I would do is I would go through and evaluate, write the actual value for each of these boxes. Okay, some of them are subtraction or addition, so just be careful of the order and make sure you're following order of operations. So go through and do that, and then it's going to be really easy to see where this maze is going to go. Okay, and then if you need to, you could even put an X kind of through the ones that we've already used, just to make sure you're not using those again. Basically, the ones that were already used are here, down at the bottom. So box number 1 is out, box number 7 is out, so we can keep going as long as we're not using those again. All right, so again, go through, find the values of each of these, and then you're going to choose the box that touches the one that you're at. You can choose the box that has the smallest value out of the ones that are touching. It's not smaller than the one that you're in, but the smallest out of all the ones that we can go to. Again, if you have questions, just leave a comment and I can clarify. Okay, so here we have an inequality. An inequality is kind of like an equation, but the difference is we don't have an equal sign, we have a less than or greater or less than or equal to or greater than or equal to sign instead. All right, I'm going to rewrite this. So -2 times the quantity x plus 4 and then minus 2x, and all that is less than 20. Okay, so we have one variable, and we're going to solve it for x. So when we solve for inequalities, we don't just get a number like x equals 5. So we're going to have a range of numbers, and we're going to show that on the number line in a little bit different way than we had been answering these type of problems when it was just equations. So we're going to start off with kind of solving this just like we would normally, and then we'll see what happens towards the end. So first step is distributive property, right? So take this -2 times x, and then -2 times 4. So that'd be -2x minus 8 minus 2x is less than 20. Combine like terms. So we have -4x minus 8 is less than 20. And then just like when we solve equations, we want to get rid of everything around the x, the same side of the x, so that we can isolate the variable. So that leaves -4x is less than 28. Okay, so now we need to divide by -4. So here's one thing that we have to remember. When we have inequalities, when we divide or multiply by a negative number, then in the next step, we need to flip that sign. So I'm going to scoot it over just a little bit. So I'm going to have x on the left side. I'm going to flip it, and then the right side is -7. Okay, so before we go any further, let's check our answer, because inequalities can be a little tricky. So we want to make sure that we did flip our sign correctly and that we needed to. So that's going to go over here on the bottom right. How do we know our answer is correct? So this is how we're going to check our answer. And we're going to substitute a number that's greater than -7 and see if our original inequality is still true. So think of a number that's greater than, so I'm going to choose an x. So x is not equal to -7. Okay, it's greater than -7. So that's what we think. So any number that's bigger than -7. So think about that. So bigger, and we're just talking about a number line here. Let's just use this number line that's here. It's an open number line. I'm going to put my 0 right here. So the -7 is somewhere over here. And then we're going to graph it with an open circle. And then any number greater than. So greater means to the right. Okay, so any number that's over here to the right of -7 is a possible answer. So when you do this, choose something that just seems like it's going to be the easiest to check. Because easiest to check means the least amount of mistakes. So I'm going to choose 0. 0 is greater than -7. So that should be a number that when we substitute it in, this inequality is true. So let's see. We have -2. Instead of x, I'm going to put a 0. Then everything else stays the same. So anywhere I see an x, I'm going to put a 0. Okay, I'm going to put a question mark above that because that's what we're trying to figure out. Is this still true? Is the stuff on the left still less than 20? Okay, so just using order of operations. So -2 times 0 plus 4 is 4. And then -2 times 0, that's just 0. So that goes away. So we have that. Okay, so when I multiply the left side, I get -8. And that is definitely less than 20. So that checks out. So that works. And you could try it again with any of these numbers. You could try with a +2 because that's on the right side. We could try -1. Okay, any of those numbers you can try and it should work. Okay, so we did it right. We got the right answer. So now we can put a box around it and then our graph is done. Okay, so the reason we have an open circle is because this is just greater than. If it was greater than or equal, then we would use a filled in circle and then draw our arrow, but it's not. Okay, so that's it for that, and that's it for day 12.